All right, so today we're going to explore a blueprint for something we all crave: certainty, especially in places where it matters most, like safety inspections. Because, when you're talking about high stakes judgment calls, shouldn't there be a way to get it right every single time? I mean, really think about this. When an inspector walks into a daycare or a nursing home, we just assume their report is the absolute truth, right? But is it? What happens when two different inspectors check out the same place and they come to completely different conclusions? See, this isn't just some abstract question. When that judgment is inconsistent, the consequences can be, well, they can be severe. If an inspector misses a violation, people can get hurt. On the flip side, if they cite a violation that isn't really there, it just creates a ton of unnecessary work. So getting that consistency has always been the goal, and a huge, huge challenge. And that brings us right to the heart of the matter, what researchers and human services call the reliability problem. For years, the whole field has been wrestling with this idea of inter-rater reliability. It's a fancy term for a simple problem. Different inspectors, or raters, look at the exact same situation and, well, they just don't agree. This isn't some small detail either. It's a really high-stakes problem that can pretty much undermine the entire system. So, how in the world do you fix a problem that's rooted in something as human as subjectivity? Well, one idea is a surprisingly simple but really powerful organizational tool. It's called the Uncertainty Certainty Matrix, or UCM for short. And at its core, it's just a simple 2x2 grid. It's designed to bring some real mathematical clarity to decisions where there's no gray area. Either a rule is being followed or it's not. Yes or no? So here's the basic idea. Look at the grid. On one side, you have the actual state of things, the ground truth. On the other side, you've got the inspector's decision. Now, when those two match up, you get agreement. That's certainty. That's what we want. But when they don't match, that's where you get disagreement. And that's where the uncertainty and the real danger starts to creep in. Now, this disagreement comes in two flavors. A false positive is when an inspector says a rule is broken when it actually isn't. Okay, that's a hassle, it causes a headache, but then you have the false negative. This is when an inspector says everything's fine when a rule is actually broken. And that is the real villain of this story. False negatives are what put people at extreme risk. So the real magic of this simple little grid is how it works as a diagnostic tool. By just plotting the inspection results onto this matrix, you suddenly see these hidden patterns of error and bias just jump right out at you. In a perfect world, right, every single inspection chart would look exactly like this: a nice, clean diagonal line. It just means the inspector's decisions are consistently matching up with reality. This is the visual signature of a system that's actually valid and reliable. But what if the results look like this? Just a random scattershot all over the place. This pattern is telling you that the decisions are no better than a coin flip. There's basically zero connection to what's really happening. This is a system that has completely and utterly failed. Okay, now things get a little more interesting. See this horizontal line? This reveals a really specific positive bias. It means the inspector almost always decides a place is in compliance, no matter what the actual situation is. They're being consistently and kind of dangerously too lenient. And here's the exact mirror image: a negative bias. This inspector is the opposite. They're consistently too strict. They decide that facilities are not in compliance, even when they totally are. In just a single glance, this UCM makes these hidden tendencies crystal clear. So, this matrix is obviously a powerful tool for looking at individual inspectors. But what if we took that same logic and scaled it up to analyze the entire regulatory system? This is where the differential monitoring matrix, or DMM, comes in. It's a twist on the UCM's logic. So instead of comparing an inspector to reality, it compares whether a single rule is followed against a facility's overall performance. The whole goal is just to figure out which rules actually matter. Yeah, the setup here is a little different. On one side, we've got high and low performing facilities. On the other, we have whether or not a specific rule is being followed. This completely shifts the focus from the inspectors to the rules themselves. It lets administrators see which rules are actually doing their job. So what does all this let you do? Well, three really key things. First, you can find the predictor rules, the ones that the high-performing places always follow and the low-performing ones often break. Second, you can prioritize the truly high-risk rules that absolutely must be followed, no exceptions. And third, and this is a big one, you can identify and either fix or just get rid of the terrible rules, the ones that don't predict a thing about safety and are just creating noise. At the end of the day, this isn't just a data table. It's really a conceptual blueprint for building certainty and reliability right where it's so desperately needed. So let's just quickly recap the power of this framework. It lets you unmask those dangerous false negatives. It visually shows you hidden inspector bias. It helps you separate the effective rules from the useless ones. And maybe most importantly, it gives administrators a real, data-driven tool to build a system that is just fundamentally better at keeping people safe. You know, as the author of this proposal says, this is the fundamental issue. Without a solid way to measure what's really happening, you're basically just guessing. It's that old saying, right? Garbage in, garbage out. The UCM provides a way to make sure you're getting good data in so you can get reliable safety outcomes out. And that kind of leaves us with one final thought. This model was designed for human services licensing, but its logic, it's universal. It's a tool for bringing clarity to any decision where accuracy is critical. So it makes you wonder, what other parts of our society, from hiring people to medical diagnoses, could be made clearer and a whole lot fairer with a simple grid like this?